Ow! Has that ever happened to you?
Well, it happened to a guy back in the 1600s, and his name was Isaac Newton. Hello, and welcome to the first 3 laws of motion by Isaac Newton, presented by Ethanol Alexander. Isaac Newton was born January 4th, 1643, at Woolsthorpe Manor, and allegedly at the age of 23, he was hit in the head with an apple when he was sitting under a tree. The story may not be true, because it was allegedly never proven, but that's what everybody bases it off of, so I'm just going to stick with that. But he thought up of the theory of universal gravitation, and also came up with a couple laws by using astronomy and studying the works of earlier astronomers such as Galileo and Copernicus. Also using mathematical formulation, universe application, and by observing the natural world. So, today we are going to be looking into the first 3 laws. And so, we're going to be starting off with the first law of inertia. And so, to start that off, let's take a trip down to a pool table.
Newton's first law states that if an object is in motion, it'll stay in motion unless a force is acted upon it. It also states that if an object is at rest, it will stay at rest until a force is acted upon it. Cue ball, it ain't moving, so it's at rest. But I'm gonna use this. This is gonna be the force that makes it go forward. Let's run that back in slow motion to see what's really going on.
The cue ball sat stationary on the pool table, representing an object at rest. But when I strike the ball with the cue stick, I applied an external force which set the ball in motion.
That concludes the first law.
What are you doing? Get out of here! Sorry about that. Now on to the second law of motion. So Newton's second law says that force equals mass times acceleration, or FMA for short. Force being a push or pull exerted on an object, causing it to change its motion or shape. More force is needed to speed up objects with more mass, and less force is needed to speed up objects with less mass. Mass is the amount of material an object is made of. The weight of an object depends on the mass. And acceleration, that is the rate at which an object's velocity accelerates. So we're going to test that on this truck. I'm going to exert force. I'm going to exert a pushing force on it, see what happens, and I'm going to exert a pulling force on it, see what happens. See if the object accelerates or stays the same. So, let's see what happens. Starting with pushing. As you can see, the object did not move or accelerate at all. It stayed in the same exact place, and it did not move. So let's see what happens if I try to pull it, if there's going to be any difference. There probably won't be. As you can see, the same thing happened, nothing happened. So, let my good friend, myself, explain what's going on.
To put it into simpler terms, there was a lot of mass in the truck. The amount of force that I was applying was not enough to make the acceleration increase, so the acceleration stayed the same, and that will be very different when we go and do the little truck.
Thank you, me. So now we're going to do the exact same thing, but with this Optimus Prime. He willingly volunteered. So we're going to do the same thing. We're going to go down to the driveway and do that. And now we're going to do the same thing, but with Optimus Prime right here. So we are going to start with a pushing force. Let's just see what happens. So, it went a lot farther than the truck. Why? Let my good friend explain it.
when he was pushing the little truck, since the mass was lower than the big truck and the force was the same, he made the truck go fast because the mass was the force that was being applied was small, was much more than needed for this vehicle. So that's why it went super far when it did that. And please let me out of your basement.
Oh, you're done. Thank you for that amazing demonstration or explanation. And now on to the third and final law, my favorite. So Newton's third law states that every action has an equal to or opposite reaction. And what better way to demonstrate that with a shotgun? So I'm gonna get my stuff together. There's none.
Let's run that back in slow motion to see what's really going on. When the shotgun was fired, the action force is the explosion of gunpowder propelling the pellets forward, while the reaction force is the gun recoiling backwards. The force pushing the pellets out is the same force pushing the gun backwards, thus demonstrating the third law of motion. And with that, the three laws of motion have been explained.
And now you know the three laws of motion by Isaac Newton. Now, if you excuse me, I'm gonna get back to my book.